Hi everyone. In the previous class, we have seen how to construct an up counter. Hi everyone. In the previous classes, we have seen how to construct asynchronous up counters or how to construct asynchronous down counters. We have seen with various kind of examples, right? So there we have specifically constructed either individual circuits for up counters or individual circuits for the down counters. Now the question is, can we able to construct any kind of a circuit which can provide both the operations simultaneously based on the input? So I can call as up or down counter. Means my criteria here is, why can't we go for taking a single circuit which can provide either up counter or down counter depending upon the inputs what the user is asking, right? So for that, basically what you can do, guys, so earlier class also we have seen one kind of adder called parallel adder, and we have seen separately parallel subtractor also, right? So the design criteria comes into the picture if I try to think that why can't we go for a single circuit where it can add parallelly either addition or subtraction. Then what I did, I have taken the existing earlier circuits itself and try to make it doing something on that so that it can work both either adding or subtracting, right? So there what I have taken some kind of control line with some value as m. If m value as 0, it can act as a addition. If m value as 1, it can act as a subtraction. Like that I have constructed. Similarly, here also we can go for the same procedure. For example, if I try to take let me go with the 3-bit up or down async counter, because earlier videos I have taken only the 3-bit up counter, 3-bit down counter. So if I am going to go with this example, you can get the clear idea as all are related to same kind of thing. So I am going to take one more flip-flop, and here also I am going to take another kind of flip-flop, right? So this is J0, K0, J1 and K1, J2 and K2, and it is going to produce the Q2, Q1 and Q0, and as usual I am going to apply some negative edge triggering, and for all these values I am going to pass the toggle operation. So means for which kind of thing it is going to perform the toggle? For the value of J and K as 1, it is going to perform toggle, right? Now try to observe, guys. So basically now based on the way that you are trying to connect, it can work like a kind of negative like the up counter or down counter. See, for example, if I try to do like this, it can act as, now I hope you remember this one. Now this will be a kind of, so green color defines a kind of up counter, right? Suppose for example, if I try to go with some other color, if I try to connect this one, the Q0 bar to here, then this will act as, so this ash color will act as a down counter. I hope you remember this one, right? So if I try to record these values, QA and QB, this will be QC, right? If I try to record these values, it will be up counter. If you try to record the ash values, you are going to get, I mean Q0, Q1, Q2, they are going to be down counters. But the question is, why can't we construct the circuit where it can select the clock signal, right? So if I pass the Q0 as input, signal, then definitely it is going to work as a up counter. If I pass the Q0 bar, it is going to work as a down counter, right? So is there any situation, you can have a question, is there any situation where you can select one line, from multiple lines? Just think about it. Yes, guys, if you take out some kind of mux called 2x1 mux, what it is going to do? It is going to perform by taking two lines as input, and it is going to produce one line as output, right? Yes. See, if I go with this one, if I try to take 2x1 mux, if it be connected like this, and if it will be connected like this, it is going to produce the output like this, right? So if I try to take this, is a kind of 2x1 mux, right? Similarly here also I will take one more 2x1 mux, it will be connected like this. Yes. Now why can't we think, right? Is this works as a kind of 3-bit up or down counter? Yes, definitely, right? 3-bit up or down async counter. But here you may get question, right? Sir, which line is going to be selected? Which line is going to be selected, right? Based upon the control line what you are trying to pass, it will be defined, right? So what I can do now, I will try to select the line here as some m value. If I pass m equal to 0, obviously the top line is going to be selected from all the locations, and that signal is going to be passed. If I pass m equal to 1, so meaning that if I pass m equal to 0, then the circuit will act as a up counter. If I pass m equal to 1, then it will act as a down counter. I hope you understood, right? Yes. So you require to have the knowledge of mux, right? So instead of this one, why can't we go for, see, if you have the clarity, if you want the clarity, I am going to draw with between the two flip-flops. I don't want to go with multiple flip-flops. I hope you understood it, right? If I am going to have 2x1 mux, this Q0 will be connected here, this Q0 bar is going to be connected here. It will be like this, right? This is Q0, this will be Q0 bar, right? If I am going to have control line m equal to 0, then this signal is going to be passed, guys. This signal is going to be passed. If I am going to have m equal to 0, the respective signal is going to be passed. If I am going to have m equal to 1, the second signal is going to be activated. That's it. Based on this concept, I said like it is acting as a 3-bit up or down asynchronous counter, right? So instead of having the mux, can we go for with simple basic combinational circuit? Yes, right? So if you remember earlier how this mux is going to work, basically, so it is going to have two lines as input, it is going to produce one line output, and we are going to have one select line, right? This will be I0, this will be I1, this will be output Y, right? So Y means here some kind of clock signal, right? Yes. If it is going to be a clock signal, what will happen? So can we construct the truth table here? Yes, right? If you are going to construct the truth table, I0, I1 are the inputs, S is the select line. S is select, right? When S is 0, I0 is going to be selected, and I1 is not going to be selected. When S is 1, I0 is not going to be selected, I1 is going to be selected, right? In other words, if I would like to write, so Y can be written as S bar into I0 plus S into I1. Am I right? Y equal to S bar into I0 plus S into I1. Right? So instead of the same thing, can I write like in terms of other thing, right? So what I can do now, I will try to take in terms of this pictorial representation. Here I can take this as Q0 and this as Q0 bar, and this is a 2x1 mux, and I am going to consider one as output, right? That is the clock signal what I am trying to pass. So select line is here M. Here is M, right? Yes, that's it. So now can I replace the circuit with this particular thing? Yes. So what we can do now? If I am going to have this particular thing, good. So now instead of having the mux, I will go with the basic circuit. So basic circuit is, if I try to redraw the value of y, I can write as m bar q naught bar. So I naught is q naught bar, right? Sorry, I naught is q naught only. So this is I naught and this is I1. M bar q naught plus m into q naught bar plus m into q naught bar. Okay, so think about this equation. Can we be able to go over the circuit? Yes. So what we can do, I am going to have J naught K naught J1 K1 I am going to have first thing as one clock signal, and all these are going to be connected with 1 as input. This is a kind of J2 K2, this will be kind of Q2, and here it will be Q1, here it will be Q0. Guys, you need patience to draw all these things. So between this, instead of having the mux, can we go for placing our own circuits? Yes. See, basically if I am going to have the value of m, I am passing the m at this point of time. M I passed. If I passed m bar q naught, so q naught has to be connected with m bar q naught, and it should be m bar connected, m bar q naught. Yes, done. Plus m into q naught bar plus m into q naught bar. M is something like this one only, m into q naught bar. Done. You have to go with the some kind of OR gate, and finally it will be connected like this. That's it. So now this circuit will act as a 3-bit up or down counter. Same circuit I am going to redraw here. So here the equation is going to change, right? Yes. So it will be connected like this. Hope you are understanding. OR gate, and it will be connected. No, this should be a signal, right? Right. So here also it should be a kind of clock signal. Right. This is the corresponding circuit diagram for 3-bit up or down counter without using mux, right? With basic gates. Okay. I hope understood clearly. Thank you.